we're going to continue studying resonance, and I want to remind you a few rules when drawing resonance structure. Remember that we're going to draw arrows like that, and the arrows show the flow of electrons. So from the source to where they're going to be. Then we remember not to break single bonds. That's one thing we need to remember. And another thing we need to remember is to say 1, 2, and then octet rule. And here we need to know what is for the elements in the second row or the second period of the periodic table. So here we're interested, say, boron, carbon, nitrogen, oxygen, fluorine for the most. So those do not exceed 8 electrons around, meaning for bonds also. Now, we're going to recognize today patterns that repeat in resonance structures so that we can draw easier resonance structures. So now, one first pattern that we're going to see is, for example, I'm going to write allylic. Say that I have double bond, and I'm going to have this oxygen here with lone pairs. And here we need to remember the formal charge, an oxygen with only one bond and 3 lone pairs as a negative formal charge. Now that is what we call that pattern allylic lone pair. That is, here we need to remember what do I mean by allylic. So in a double bond, the positions here with the circle are vinylic. And I'm going to put a square here. That position here is allylic. So now, notice that relative to the double bond, the lone pairs are allylic. Now, I will move those. And again, notice this rule. Arrows need to show the flow of electrons. So starting from the electrons, I'm going to move over here. And then I will move also electrons over to that side. And I'm going to draw now the resonance structure that result from that movement. So we use this double-headed arrow to represent the next resonance structure. And I'm going to draw it a little bit to the side. And notice here I am creating a double bond with the oxygen. Now I have only those 2 lone pairs. And now I have electrons here, and that is a negative formal charge. Another thing we need to remember when drawing resonance structure is always draw formal charges. And keep track of that. So if you here had overall a negative charge, here you should have that too. And this too, a resonance structure. But again, our goal here is that we're able to recognize an allylic lone pair. That's one pattern. And I'm going to erase this one to give you one more pattern that we need to recognize when we're drawing resonance structures. And here is, then we may have, this is an allylic carbocation. Oh, I made a mistake. Yeah, oh no, it was right. I thought I made a mistake. Carbocation. Say that I have that. And again, my definition. The 2 positions at the double bond are vinylic. Here is allylic. So allylic carbocation. That we will draw the resonance structures here. We will move again, rule electrons. We show the flow of electrons. And then, now because I'm moving the electrons over there and creating a double bond, now the formal charge is going to be on the other carbon. Say, have we explained that in the previous video? If I number that 1, 2, 3 in my resonance structure, then I will have a double bond between carbons 2 and 3 and a positive charge here. So that is another pattern. Recognizing that pattern number 1, allylic lone pair. Pattern number 2, allylic carbon cations. Those things I want to recognize in resonance structure. And let's erase that to give you another pattern that we should be able to recognize when we are doing resonance structures. And that pattern is, say that I have lone pair adjacent to a positive charge, like this one here. Now, when you recognize that in that pattern, you will do this arrow. And then the resonance structure that results from that movement is the following. Now, you will form a double bond here. And now this oxygen has 3 bonds and 1 lone pair, so it has a formal positive charge. So these are 2 resonance structures. And that's, again, that is a third pattern. We said lone pair adjacent to a positive charge. Another pattern. And I'm going to give you another pattern, but I guess I'm going to, in the next video, so please remember those. What did we do in this one? So we said allylic lone pair first. So we studied this one. So this is allylic lone pair. That is my vinylic position, so allylic is here. Then we did allylic carbon cation in third pattern. Lone pair adjacent to a positive charge. That's, we see a couple more patterns in another video. Oh,
No, hit the stop recording.
I did. I did it? Oh, I thought I did. I didn't? Why not?